traditional AI models need huge amounts of labeled video data, making it difficult to apply them in new tasks. But what if could train an AI model just once and use it everywhere? Dear friends, FACET provides a dataset of 32,000 images manually annotated by experts to label attributes such as skin tone, hair type, and even occupation like guitarist or a disc jockey. So this breakthrough will be a boon for video editing, film restoration, and allowing for ultra-realistic AI-assisted content creation. Dear friends, have you ever seen two buildings that look identical but are actually different? AI faces the same problem in 3D reconstruction, mistaking visually similar structure as the same object. Happy morning, dear friends. Here's yours, Dr. Ajay. Welcome to Demystify with Ajay. Dear friends, today we are diving into some of most exciting research advancement in artificial intelligence, particularly in image recognition, video analysis, segmentation, and reconstruction. Dear friends, imagine an AI system that can not only recognize faces and objects but also ensure fairness across different demographics. Picture a video AI that can track objects effortlessly, inpaint missing frames with near perfect accuracy, or segment an image with just one example. Sounds futuristic? Yeah, well, it's now happening, dear friends, and in this episode we will break down 6 groundbreaking research papers, each paving the way for smarter, fairer, and more efficient AI models. Let's get started. The first comes on image recognition, so FACET, Fairness in Computer Vision Evaluation Benchmark. Dear friends, we often hear that AI can be biased, but how do we measure and fix these biases? Enter FACET, a new benchmark designed to evaluate fairness in computer vision model. AI models trained for tasks like image classification, object detection, and segmentation have been found to perform differently across demographics, meaning that an AI might recognize certain groups of people more accurately than others. This raises ethical concerns, especially in fields like law enforcement, hiring, and healthcare. Dear friends, FACET provides a dataset of 32,000 images manually annotated by experts to label attributes such as skin tone, hair type, and even occupation like guitarist or a disc jockey. So by using this FACET, researchers can test whether their model are biased and take steps to reduce discrimination in AI-powered application. And towards the result, or eye-opening, current AI model still shows significant disparities. So this benchmark is a major step toward building fairer and more inclusive AI systems that work equally well for everyone. The next paper, Contrastive Future Masking Open Vocabulary Vision Transformer. So it is shortly specified as like CFMVIT. Okay, dear friends, imagine an AI that can identify object it has never seen before. That's the goal of this open vocabulary object detection, shortly specified as OVD, where AI learns to recognize new object from image text descriptions. So, however, current method struggles with learning fine-grained object location, and combining this CFMVIT is a game changer. Unlike traditional AI models that reconstruct images pixel by pixel, this CFMVIT does something unique. Yeah, the first one, it reconstructs missing image parts in a joined image to text, embedding space rather than raw pixel. Interesting, no? Okay, fine. The next one, it introduced positional embedding dropouts, that is PED. So, a technique that prevents AI from forgetting how to detect objects when fine-tuned on new tasks. And towards the result, yes, dear friends, this CFMVIT outperforms previous methods by 7.6 points on the Lewis benchmark, making it a leader in zero-shot detection and image text retrieval task. This means AI-powered search engines, autonomous robots, and AR applications can now identify and understand a much wider range of objects with a greater accuracy. Okay, next topic, it is on video analysis and understanding. And the paper is tracking anything with decoupled video segmentation. Or shortly, it is specified as like a DEVA. Okay, so yes, dear friends, video segmentation is crucial for applications like sports analytics, autonomous vehicles, and surveillance, of course. But training AI for it is extremely expensive. Traditional AI models need huge amounts of labeled video data, making it difficult to apply them in new tasks. But what if could train an AI model just once and use it everywhere? Yeah, that's exactly what decoupled video segmentation approaches does. Instead of training an AI for every video task, this data splits the problem into two parts. That is a task-specific image-level segmentation model which can be trained separately on images. And a universal temporal propagation model which generalizes across video without extra training. And by combining both, of course, dear friends, this data can track any object across video frames, even in scenarios where there's limited training data. So this makes it a cost-effective solution for large-scale video understanding and opening doors to smarter AI-driven surveillance, movie editing, and autonomous system. Okay, next it is on ProPainter, improving propagation and transformer for video Inpainting. Dear friends, ever wondered how movies restore damaged or missing frames in old footage? Or how AI can remove unwanted objects from a video? That's where video Inpainting comes in. Current methods rely on two techniques. The first one, flow-based propagation, that is which can cause misalignments due to optical flow error. And second, spatiotemporal transformation, that is which require heavy computation. And here ProPainter introduced a dual domain propagation method merging image wrapping and future wrapping for improved consistency. Additionally, it discards unnecessary tokens during processing, making it far more efficient than previous approaches. And towards the result, yes, 1.46 dB improvement in PSNR, meaning sharper, more realistic video reconstruction. And next, faster and more efficient AI-powered video restoration. So this breakthrough will be a boon for video editing, film restoration, and gaming, allowing for ultra-realistic AI-assisted content creation. Next, it is a slime, segment like me. This paper comes under image segmentation. Different segmenting an image usually requires tons of labeled data. But what if AI could do it with just one example? That's the primes of this slime, that is segment like me. Inspired by stable diffusion, slime extracts self-attention maps and optimize text embedding to learn segmentation from a single image. And during inference, Slime applies this learned knowledge to segment any real-world image with similar characteristic. And if you feed it more examples, the model improves even further. And this advancement makes AI-driven segmentation more accessible and practical, benefiting applications like medical imaging, industrial inspection, and even digital art. Okay, next it is on image reconstruction, and the paper is Doppelgangers, that is learning to disambiguate images of similar structure. Dear friends, have you ever seen two buildings that look identical but are actually different? AI faces the same problem in 3D reconstruction, mistaking visually similar structure as the same object. Doppelgangers introduce a learning-based visual disambiguations method, that is, analyze local key points and spatial distribution to determine whether two images represents the same or different 3D structure. And it uses a new dataset of challenging image pairs, improving accuracy in SFM, that is structure from motion pipeline. This is crucial for application in urban planning, virtual tourism, and AR VR, where precise 3D models are needed. Okay, dear friends, yes, the AI revolution is not slowing down. These breakthroughs in image recognition, video understanding, segmentation, and reconstruction are paving the way for fairer, more efficient, and smarter AI models. Dear friends, which of these innovations excited you the most? Drop a comment below. If you enjoyed this breakdown, like, share, and subscribe. And yeah, dear friends, we are just going to see more on deep dives into AI research. Until next, keep exploring the world of AI. Happy learning, dear friends.